Okay, so this video right here is going to be a review of what we talked about yesterday, which is moles to grams stoichiometry problems. And first, to review just basic information, when we convert moles to grams, we multiply by the molar mass. And we know the molar mass is when we add up all the individual atomic masses and multiply by the number of atoms in the formula and add them all together to get the total molar mass of a compound or a substance. So moles to grams, we multiply by the molar mass. Grams to moles, we are going to divide the grams that are given by the molar mass. So the molar mass should be, punched into your calculator second. It should be, if you're giving grams, you say you're giving 14 grams of H2O in the problem. To convert that to moles, you have to divide by the molar mass. If you add up the molar mass of H2O, it's 18.02. So you take the grams given to you in the problem, divided by the molar mass. That's how you convert to moles. Now, moles to grams stoichiometry are two-step problems. All right, we'd already worked like one-step problems, going moles of one substance to moles of another substance. But basically, if you're given moles to begin with in the problem, if you're given moles and you're asked to find grams, first you have to convert the moles given to the moles wanted by using the balanced equation. That's when we use the coefficients to go from moles of one substance to moles of another substance. And then the second thing is you simply convert the moles that you have calculated from step number 1 to grams by multiplying by the molar mass. Do not use the coefficients in the problem, in the balanced equation. You only use the molar mass of the substance. Those coefficients in the balanced equation is only used when you're going from moles of one substance to moles of another substance, not when you are converting moles to grams or grams to moles. Alright, so if you're if you're given grams and you're asked to find moles, if you're given grams, you cannot work in grams when you're trying to go from the amount of one substance to the amount of another substance. You have to be in moles. So first you'd have to convert grams given to moles by dividing the grams given by the molar mass. So you convert to moles, first step. And then you go from moles of your, what you're given, what you're starting with, to the moles of what you want by using the balanced equation, by using the coefficients and setting up a proportion or a conversion factor. All right, so let's look at a couple of examples. Acetylene gas, which is C2H2, is produced as a result of the following reaction. And it's CaC2 plus 2 moles of H2O produces 1 mole of C2H2 plus 1 mole of CaOH2, calcium hydroxide. Alright, now it tells me in the problem, if 2.10 moles of CaC2 are consumed in this reaction, how many grams of H2O? So if I notice, it is a moles to grams problem, so it's going to be 2 steps. This is my starting substance or my known substance. That's what I'm starting with. And this is what I want right here, is grams of H2O. Alright, so this is what the starting substance is, what's given. So if I rewrote this, reaction, I had CaC2 plus 2H2O. And that produces 1 mole of C2H2 plus 1 mole of calcium hydroxide. Basically, it's saying that I'm given 2.1 moles of this substance. And I want to go to grams, I want to know how many grams of H2O are needed to react with it. So I'm looking for grams of this. Before I can find grams though, I need to find out how many moles is produced. And I do that by setting up a portion. Now I can do this two different ways, and I've showed you different ways of doing this. Basically, my first step is going to be to go from, since I'm given moles, I got to go from moles of CaC2 to moles of H2O. Now I can do that two different ways. I can say, well, I have 2.10 moles of CaC2. I can put that over and set a conversion factor. If I'm going to moles of H2O, I will need to put 2 moles of H2O on top, because my Balanced equations tells me it's a 1 to 2 ratio. For every 1 mole of CaC2 that reacts, I get 2 moles, twice as many H2O. Then I would just multiply that out. 2.10, that equals 4.20 over 1, which is equals 4.20 moles of H2O. Now, you can work it that way. I prefer the other way. Like I said in the last video, that I'm going to just start working them out one way because it'll save on time, but you can pick whichever way is best for you. But basically, I cannot go directly from moles of one substance to grams of another substance. I can only go from moles of one substance to moles of the other substance. So I'm going to do that first. That's a 1 mole thing, so I'm going to put 1 over 2.10 equals this coefficient here for H2O, which is 2 over X. And X is going to be my moles of H2O. When I cross multiply, I get 1x is equal to 4.20. Divide both sides by 1, my x is 4.20. But now I'm just in moles of H2O. So my second step is I simply convert to grams. So I'm going to take 4.20 and I'm going to multiply by the molar mass of H2O. Now I do not look and take the molar mass of H2O and then multiply it by 2. No, that 2 is only used in this first step right here when I'm going from moles of one substance to moles of another. I simply want the molar mass of just H2O. And when you add up the molar mass of H2O, you see that it's 18.02 grams per mole. So that's what I'm going to multiply by. And then I bring up my calculator. And I get 4.20 times 18.02. And then I can round this to 2 decimal places, 75.68. And I need to put my units. That's going to be grams of H2O. And that would be my answer. So these are 2-step problems. If I'm given moles at the beginning, my first step is going to be used my Balanced equation to go from moles of my starting or given substance to moles of the what substance I want. And then my second step is going to be multiplied by the molar mass to get the grams. Now if I look at another example, and this time it says laughing gas, nitrous oxide, or N2O, is sometimes used as an anesthetic in dentistry. So how it's made is 1 mole of NH4NO3, it's ammonium nitrate, breaks down into dinitrogen monoxide, it's N2O, plus 2 moles of water. Now what I want to know is how many moles, what I'm looking for, how many moles of NH4NO3, that's what I want, are required to produce 22 grams of N2O. This is my starting substance, or what I'm given in the problem. Notice I'm given grams. So if I rewrite my Balanced equation, I have 1 mole of this this is how this equation happens on the simplest level of whole number ratios reduced down. But what it's telling me is I have 22 grams of this stuff. And I want to know how many moles of this can be produced. So I'm giving grams to begin with. What I need first, before I start the problem and use my balanced equation, I'm going to have to convert this to moles. I need it in moles before I can use my balanced equation to go to moles of NH4NO3. Right, so I'm given 22 grams. So my first step in this problem is I'm given 22 grams of N2O. I want to convert that to moles. I need that number in moles. So I'm going to simply divide by the molar mass of N2O. When I add up the molar mass of N2O, it equals 44.01. And so I'm going to divide by that to get my star given in moles. So that'll be 22 divided by 44.01, and that equals 0.499. So that's going to be 0.50. Now I'm in moles of N2O. Alright, now I'm in moles of N2O. My second step is just going to be to go from moles of N2O to moles of NH4NO3. It's a 1-to-1 ratio. So I take the coefficient that's along with N2O, which is 1, put 1 over 0.50 equals to what I'm going to. I'm going to NH4NO3. The coefficient for it's a 1, and I'm looking for the moles, which is going to be my X. Now I'm going to cross multiply, and I get 1x equals 0.50. Divide both sides by 1, and my x is 0.50. And now I'm in moles of, I went from moles of N2O to moles of my wanted, which was NH4NO3. And that's what it asked me for, was moles. This is a two-step problem. So this was right the opposite in the first problem. In this one my first step was to convert to moles of my given, which I did by dividing by my molar mass, and then I choose my moles of my given to go to moles of my wanted, what I wanted, using my balanced equation, coefficients, and my answer was 0.50 moles of NH4NO3. So all these moles to grams problems are two-step problems. And remember, whenever you are converting moles to grams or grams to moles, you do not use these coefficients. They're only used when you're going from moles of one substance to moles of another substance.